I'm going to start out by introducing two ideas to you, a dilation and a scale factor. A dilation is simply a copy of a figure. So the figure on the left is called your pre-image. And you always want to read your instructions and they'll identify, say, with the pre-image. Or they'll kind of refer to it. Notice over in these instructions it says the figure on the right is a scaled copy. So this came second. In other words, it was copied from that one. But most of the time with these type of problems, it'll say this is your pre-image. And then what comes second is called your image. Whenever we have a pre-image that's smaller and then it becomes larger, we would go ahead and we would say that this would be called an enlargement. So when you have a dilations and your scale factor, by the way, scale factor in math is typically represented by the variable k. We would say that when our scale factor or k value is greater than 1, it's going to take the pre-image and it'll enlarge it. Alternatively, if we take a figure and then it becomes smaller, we would describe this as a reduction. And then similarly, that means that our scale factor or k value is less than 1. So just remember this, pre-image comes first, image comes second. If the figure gets larger, it's called an enlargement, which means that our k, or scale factor, is greater than 1. Whereas if the figure gets smaller, it's called a reduction, and that means our k, or scale factor, is less than 1. So in our first problem, they actually, here I got the answer here already for this one. In our first question, in Google Classroom, it said write down the scale factor equation. Our scale factor equation simply has us finding the length of the pre-image, one of them. Now in this figure, they're actually asking for the corresponding side length to SP. The word corresponding simply means same relative position. So in this one they said SP, well the same relative position in the image is going to be from M to L. So we'll come over here and we'll do ML. Now the calculations that they're going to ask for in Google Classroom says the scale factor equation, so we're going to take the length of one side from the pre-image. You can use whatever length you want. Now because they asked for SP and ML, that doesn't mean you have to use the length of those. In fact, I wouldn't, because finding the length of a diagonal would involve using the Pythagorean theorem, and that's more work. So I would not use SQ and MN. So we would be left with either this horizontal segment of PR and this horizontal segment of LO, or you could use a vertical segment of QR and the vertical segment of NO, because horizontal, for example, the length of this is 2, the length of this is 4. When it's horizontal and vertical, you just count the spaces and you got it. Anyways, here's the scale factor equation. Pre-image multiplied by scale factor. And when you take a pre-image, any length in that side, and multiply it by the scale factor, that's going to tell you the exact length of the corresponding side. So again, the advice, we're not going to use diagonals. And in fact, I would always go ahead and use a horizontal or a vertical. I'm going to go ahead and use QR as an example. The length of QR would be down 1, 2, 3, 4, so that has a length of 4. So I'm going to go 4 multiplied by the scale factor, which is k. We're going to find out what that is in just a moment. And then the length of NO would be 1, 2, 3, 4, 5, 6. 4 times k equals 6. That'll simplify to 4k equals 6. And then we'll divide by 4 on each side, and we'll find out that our k factor is actually equal to 6 over 4, which does reduce to 3 over 2. So that's actually our answer to this question right here. Now, again, the advice I gave you is always look for horizontal or vertical lengths. I want to show you how this one ended up being 4 to 6, but watch this. What's the length of this one? We could also use this horizontal length. That's going to be 2 multiplied by the scale factor. Well, what would be the corresponding length to PR? Well, that would be 3. And then notice to solve for k, if I simply divided by 2 on each side, we would get k is equal to 3 over 2. So either way you have it. So my suggestion would be look for horizontal or vertical corresponding lengths and then just use the shortest side that's quicker. So we'll answer this question and say what's the scale factor. So the scale factor for this is going to be 3/2. We got it. Okay, so that obviously our K value was 3/2, and 3/2 is definitely an enlargement. So let's see if I can find one that has a reduction. Okay, so we have another figure. Obviously the pre-image is larger and the image is smaller, so this is a reduction. To answer this question, which side of the figure on the right corresponds to the segment of PO? So PO is this horizontal segment along the top, and corresponding it would be, let's see, from P to O would correspond to T to Q. So there's T to Q. To find the scale factor, we're going to use the equation, which states that we find the length of one side on the pre-image. We'll multiply that by the scale factor. And that's going to go ahead, and it helps if you spell it correctly, pre-image times scale factor is going to give you the length of the image. So again, the suggestion I'd say is don't use diagonals, so I'm not going to use these two. And I'm going to use this horizontal length here or here. And this looks shorter, so I'm going to use this one. This is probably going to give me my reduced length. So this has a length of 1, 2, 3. So 3 multiplied by K equals, well, the corresponding length, P to N, would correspond to T to S, and T to S, that's 2. So that would simplify to 3K is equal to 2. And then we'll divide by 3 on each side. And so we'd find out that our K value is 2/3. And then again, notice that 2/3, that's less than the number 1, so obviously this is a reduction. So I'm going to come over here, I'm going to show you that it's going to be 2/3. Before I move on, I do want to, you don't have to show it a second way, but notice if I had found out if I had used O to P, that would be 1, 2, 3, 4, 5, 6. So that would be 6 multiplied by K, which is our unknown, and then the corresponding length would be 1, 2, 3, 4. So divide by 6 on each side, and then notice that K is equal to 4/6, which also reduces to 2/3. So again, you're going to get the same scale factor. Use the smaller or the sides that have less numbers. It's just a little bit easier for you.